Hey, y'all. Let's see how well you can remember decimals, like adding, subtracting, multiplying decimals. If you're like, got it, and this will be a great lesson. If you're like, oh, I don't remember anything about decimals, this will be an even better lesson. So I'm going to remind you how we add, subtract, multiply, and divide decimals. Let's start with dividing decimals, or just dividing in general. When do we divide? Dividing is when we subtract something over and over and over again. Let's say you have 100 cookies and you're going to give everyone 2 cookies. How many people can have 2 cookies? Well, you're going to give that person 2 cookies and that person 2 cookies and that person 2 cookies. Yeah, I'm subtracting 2 every single time. You could keep subtracting and subtracting and subtracting to get to 0, or you could just go 100 divided by 2. Okay, so that's division. When you're sharing something equally, when you're sharing 100 cookies, right? When you're dividing cookies up, when you're dividing anything up, money, erasers, friends, I don't know what you divide up, or when you're putting stuff into equal parts. If you're getting your Valentine's things ready and you want to do cute little gift bags and you want to be fair to everyone, you're going to give everyone like 5 Starbursts, right? That is dividing. Also, when you hear the word each or per, and you're given the total and asked, well, how much is that for each person or per bag? That's dividing. So let's remind ourselves how to divide. I got some little hints up here. So what we want to do is we want to put the decimals out of the way. So let's start with the first number always goes inside. That is called our dividend. The second number, the divisor, goes on the outside. Now, it's okay to have numbers inside. We'll just pop those straight up, right? But if we have numbers on the outside, we need to scoop those out of the way. And then to make sure that we keep the 2 numbers equal, or so that the answer will be the same, we are going to scoop that same number of times inside. And like I said, even if you don't scoop it all the way out, and it stays inside, that's fine. You'll just then pop it straight up. So this is basically now 35 into 163.8. Okay. Now, last thing I want us to remember when we are dividing decimals is to carefully place your zeros. The way that I do that is I think, how many times will 35 go into 1? Well, 35 is not enough to go into 1. It's not even enough to go into 16, but it can go into 163, which is why our first number is going to be above the 163, the 3. Okay, and we're going to think, well, how many times can 35 go into 163? I'm going to try 3. 5 is good to start with if you have no idea, because then you know you can get higher or lower, but we're going to start with 3 here. And that will give us 9, 10, that'll only give us 105. So yeah, maybe I should have started with 5, because that will give me 175, which is too much. So I'm going to start with 4 now and see where that gets me. 12, 13, 14. Ooh, I like that one. So what I'll do now is I'll put 140 here on the bottom and the 4 up here on top, because 4 times 35 is 140. That's why I use those 3 numbers right there. I will subtract now and get 23 and bring down the A and get 238. Now, when we divide decimals, I never, ever, ever erase any of that work because I may find it useful later on in the problem, which I know that my answer is going to be more than, oops, let me bring down the 8, more than 5, because that only got me to 175. So I'm going to try something bigger like 7. See where that takes me. 21, 22, 23, 24, 245, which is too big. So let's go with 6. I'm not doing very good at guessing, am I? 18, 19, 20, 21. So we're going to have to go with that. 210. And that will give me 48. Now, if you need to, when we are dividing decimals, add another 0. You can, as long as it's behind the decimal, because 0 cents is the same as no cents at all, right? So we can add zeros after decimals, pop them down, and keep going on with our problem. So I'm trying to get to 480 now. I'm going to try, oh, guys, this is not correct, is it? Oh my goodness gracious. Are you guys yelling at me? That is not correct. Back up, back up, back up, back up, back up, back up, back up. 3 minus 1 is 2. Okay, there we go. That looks so much better. 24, 25, 26, 27, 28. Oh, yes. Yes, look at that. I can get it perfect. So I'm going to say that's 8. And I'm left with an answer of 4.68. Here's how I knew that that was wrong. When I had 48 right there, if that truly was my remainder, that means I could have put in another 35 and gotten more, right? So that's what got me thinking. All right, so that's dividing decimals. Let's move on to multiplying decimals or multiplying. When do we multiply? Well, it's the exact opposite of division because they're inverse operations. Multiplying is when you add over. Oh, I gotta stop my printing. Oh, nope. Never mind. I thought I was printing something wrong, but it's printing good. Okay. So because multiplication is the inverse of division, it's the opposite. Whereas division was when we subtract over and over again, multiplication is when we have an example in real world where we're adding over and over and over again, okay? The word of is sometimes used to signify that you're going to multiply, and each and per. Same with division, only this time if it gives you the part, but then asks you to find the total amount. Those are your clues to multiplication. So how do we multiply? Well, this is my favorite key, and that is to don't even worry about the decimals until the end. So you can pretend that this is 375 times 55 and set it up that way. How would you set it up? Well, I would set it up just like this, right? And then I'm going to times everything. I'm going to change my color. I'm going to times everything by the 5. So 5 times 5 is 25. 5 times 7 is 35, 36, 37. 5 times 3 is 15, 16, 17, 18. Okay, so now I'm going to times everything by 5. But that's not in the ones place value. That's in the tens place value. That's actually a 50. And when we times anything with something that ends in a 0, well, then it's just that number with a 0 added on the end. So that's why we always put that 0 there in the first place. So 5 times 5 is 25. 5 times 7 is 35, 36, 37. 5 times 3 is 15, 16, 17, 18. And we're going to add it up and get this number right here. Now we're done with the multiplication part. We're going to go back to the decimal part. Here is what I know about this number actually. It's actually 3.75 and 5.5. So if I were to put those decimals in here, the next thing I need to do is I'm going to count how many numbers are behind the decimal. There's 2 numbers behind the decimal there. 1 number behind the decimal there. That's 3 numbers behind decimals. So I want my answer to also have 3 numbers behind the decimal. 1, 2, there's my 3 numbers behind the decimal. So that is how you can place the decimals. The other thing you could do is take this and round it really fast. 3.75 is close to 4. 5.5 is close to 6. 4 times 6 is 24. Is 24 close to 20? Yeah. Okay. So there's a couple ways where you can place, couple strategies for placing the decimal in the correct spot. Okay. Adding and subtracting. This is when you're adding things together. You're putting things together. You're adding on to things. I like to think when I'm thinking of adding and subtracting decimals is thinking money. And that helps me line up my decimals because if I think money, then all my cents is going to be on one side of the decimal and all my dollars are on the other side of the decimal. Let me give you an example of what I'm talking about. Here we have 125 plus 15.45, 15 and 45 hundredths. If I'm thinking money, then I'm thinking this is $125 and 0 cents. And this next one is $15 and 45 cents. Okay, so you'll notice that what I had to do is add a decimal right here and some zeros because this number didn't have a decimal, but this number did. And it is very important that you line up your decimals, even if it's invisible. If you don't see a decimal, then you think of this rhyme. If the decimal's not in sight, then you put it on the right. Okay, there's every single whole number has a decimal. It's just invisible and it's at the very end after the ones place. So then you can add some zeros there after as well. So now when I add it up, I get 140 and 45 hundredths. And that makes sense because if I have $125 and I'm adding 15 more dollars, I should get more than the 125 that I started with, right? So $140.45 would totally make sense. Okay, let's talk about subtracting. When you subtract, the fancy word is when you're finding the difference of something. So it's when you're taking away, when you're buying something and you're getting change back, you're going to be subtracting. When you want to know how much more something is, like how much taller someone is, or how much faster someone is, right? That's asking you, well, what's the difference between their height or the difference between their times, their paces? So those are examples of when you'll use subtraction. Subtraction is the same as adding in that you need to be very careful lining up those decimals. You want to keep the dollars, the whole numbers separated from the cents or the decimals, okay? One extra thing with subtracting decimals is that the first number always goes on top. Even if you're like, well, Mrs. Madsen, this number is bigger, it's got 3 numbers, we always put the bigger number on top. Nay, nay, you do not. When you are subtracting, it is always the first number on top. The first number will always tell you how much you have, and then the second number after the subtraction will tell you how much is being taken away. So always put that first number on top, okay? And whatever you do, make sure you don't do it like this. Okay, this is not lining up the decimals. There is a decimal here, but you didn't line it up with the decimal up there. Well, where's the decimal, Mrs. Madsen? Fair enough. If the decimal's not in sight, then you put it on the right. And then if you want to add some 0 pennies to it or some 0 hundredths, that is totally fine. Okay, and then I got to make sure that this matches up perfectly. So there's my decimal, there's a 9 after the decimal, and a 45 in front of the decimal. So as I subtract now, 0 minus, if I wanted to, I could add 0 there. Okay, that'd be 0. Now, if I have 0 dimes, I can't take 9 dimes away, can I? What I can do though is I can steal from these $8 and take those $8 and put them into 10 dimes or 10 tenths. And now I'll have enough to take 9 away. 10 minus 9 would give me 1 dime or 1/10 left over. $7 take away $5 would give me $2. And then 7 minus 4 is 3. So I'll have $32.10. Or I could just write 32.1 because 0 cents is the same thing as no cents or no hundredths at all. So those are the most important things that I can think of to tell you when you are dealing with decimals. So a lot of times, these are my most common mistakes, so don't make these mistakes. When students are subtracting, they don't put the first number. They put the second number on top or whatever number they think looks bigger on top. Okay, what I mean by that is right here, they'll be like, oh, well, this 26.37 is bigger, so it goes on top. It is not. Once we put a decimal here at the end, that's $41 compared to only $26.37. So make sure you put the decimal on the end and make sure that first number goes on top. It should be 41 minus 26.37. And you can add decimals and zeros. Okay. Another thing that I see is I don't see students line up decimals. They'll see this and they'll line it up here, but they won't line it up according to the decimal. And I don't know if it's because they don't see that there is a decimal there. Well, there's not a decimal there, but they need to make sure that they include a decimal if they need to, and then they line up those decimals. All right. Now, hopefully you can look at this problem and be like, hold on, I have $324 and I'm adding 97 more dollars and 26 cents. There's no way that I'd be left with $10.40. Like that's just not possible. If you have 324 and you're adding almost 100 more dollars to only end up with $10. It should be closer to like 400 something, correct? So those are the biggest mistakes that I see with multiplication. It's because of the commutative property of multiplication. Either number can go on top, so whatever makes more sense to you, you can put it in whatever order. Okay, you cannot with subtraction. Subtraction, the first number always goes on top, but multiplication, you can change up the order. Same with addition. Okay, those are my best tips that I can give you for remembering how to add and subtract and multiply and divide decimals. See ya.